Hi guys, and welcome to this webinar. Today I'm going to talk about how you as an infrastructure team can let the developers take over the hardware in the data center without losing the operational control of the infrastructure. My name is Johan Ekström. I work as a consultant at Miradot, and I'm a data center and automation specialist. Miradot is a consultancy company and a Cisco partner. We focus on data center and automation of the data centers. And this spring, we actually became the first Cisco DevNet partner in the world, which means that we are a good partner for everyone who wants to automate their data centers. This webinar is targeted for infrastructure people. You guys who are working with security, network, servers, and cloud. My hope with this webinar is to inspire you on how to enable self-service in the data centers for the developers in your organization. Before we start, let's have an overview of this webinar. First, we're going to talk about the problem that we are going to address, the mess that occurs when developers grow tired of waiting for the IT department to provide the resources the developers need. And instead they turn to the clouds or Kubernetes or other solutions without a good plan or strategy. This tends to make it really difficult for the operation teams when an incident occurred and no one has a full picture of how the involved systems are connected. Then we're going to cover a proof of concept solution that will solve this problem. And an actual implementation of a solution will have to be customized for the need of your business and your organization. And then we will have a demo of the solution. But before we proceed, we need to cover some need to knows. First, ACI. ACI stands for Application Centric Infrastructure, and it is Cisco's data center software-defined network solution, which is using software-defined network together with rapid hardware with Nexus 9K switches. It is widely supported by different automation tools such as Ansible and Terraform, which is perfect because that is what we're going to show you here today. If you'd like to know more about ACI and its capabilities and why you should use ACI as a data center network solution, let's have a call and we can schedule a separate demo for that. VMware, you probably heard about. Yeah, it's a virtualization platform, and we will create the VMs on top of that. It also have a good API that we also can implement with Ansible or integrate with Ansible to create the VMs on top of the ESXi host. Infrastructure as code is something that we also need to cover before we start. Infrastructure as code is a structured, machine-readable definition of how a technical environment, like your data center network and what virtual machines, etc., should be configured in your data center. This means it's easy to modify and replicate this to different sites. You will see later how the infrastructure as code is central in the solution that we built. Is it just me who sometimes get tired of all these developers? When they come up with new applications all the time that need new resources like VMs, or maybe a bare metal server is needed because of the hardware requirements for that application. when the developers want the application to be secure, but at the same time they want to allow all the traffic in the firewall rule. Or when the network security policy is that all the traffic between the applications need to be specified in the firewall rule, then many firewall rules requests are made by the developers. Not only that, all of a sudden there is a Kubernetes cluster that is running in production on top of infrastructure that you didn't know about. Maybe in a public cloud or in the a testing server that you're not running for production. This was maybe discovered during an incident, and now you maybe want to implement a multi-cloud strategy in the organization so that the application can be built in several clouds. Is it even possible to ensure that the same security policies you have created on-prem is also created in the public cloud? When the developer gets tired of waiting for the resources for the IT department, they create an overlay platform like Kubernetes to be able to rapidly develop their applications. We call this dilemma the shadow IT. The developer wants to create their application. They don't want to wait for a few days for a VM to be created. They want it the same day or even the same minutes or a few minutes after they requested it. They are impatient and they know that there are technologies that out there that can let them do that. So they maybe are creating a Kubernetes cluster on top of a few VMs that they have requested for the infrastructure team, or maybe they are running in public clouds instead of the on-prem that the infrastructure team are operating. With the shadow IT, no one wins in the long run. No one knows the full picture of the solution. The infrastructure teams have less insight into the infrastructure dependencies for each application it's running on, and maybe they need to evolve their knowledge of that platform before they support it. At the same time, the developer spends more time on the infrastructure part because of the platforms that they have been implemented are not supported by the infrastructure team yet. As an operation engineer, you want to make sure that you're aware of the dependencies of the infrastructure underneath each application. And you also need to make sure that the naming conventions are followed, the IP planning is followed in the network, the security policies are followed, the compliances requirements are followed for the data for the application, the SLA must be followed as well. You need to make sure that the backup and the monitoring for each application is working as well. Even if Kubernetes and public clouds are great, you will always have a legacy of applications that you're not able to migrate into containers or the public clouds, or the infrastructure engineer does not know how to support them yet. But you want to create a way for the developers to create their application in your infrastructure on premises without involving the infrastructure team, and at the same time making sure that the organization's policies are followed for those applications to be able to create a reliable application operation. We have created a proof of concept solution for this scenario by using the Git repository that developers are using for each application together with infrastructure as code. We can make sure that the resources are created in the infrastructure for each application. We use Ansible to provision the infrastructure like creating the networks, creating the VMs, installation of the operating systems, and the installation of the applications on those VMs. We are using GitLab to run the infrastructure as code pipeline to create the resources. Because we are using infrastructure as code, we can easily define the organization policies in the infrastructure as code format. We are calling this policy as code. So we are defining the what security policies that each application should use, or what compute resource policy each application should use. In our example, we will demonstrate how all networks created on premises can be scaled out to AVS without losing the control of the network security policies that we are creating on premises. By doing this, we make the solution multi-cloud ready. Enough talking. I think it's time for some demo now. First, let's have a look in a developer's perspective. Let's say the developer have a Git repository, like this repository. Here we have a Flask application, and we want that to run together with the Redis database and the MySQL database. I want all those three pieces to run on separated virtual machines. The developer has heard that the only thing he needs to do to have the application running in the infrastructure, he only needs to define the application components profile in a YAML file in the same repository. As we can see here in this YAML structure, we are calling for a web application, a Redis, and a MySQL. We also provide some attributes to the MySQL. This is not recommended to have your username, password, and the database in clear text. Use Vault or something. Before we run the pipeline, let's have a look in the perspective of an infrastructure engineer. Before I will run the pipeline, I want to show you the infra variables, the infrastructure variables that we will use to run the pipeline. Here we will have create a tenant called Ekis with the VRF called Ekis VRF. In AVS, we will pick a region and a subnet for that region, and two availability zones here, A and B. On-prem, we will have a bridge domain, which is connected to the Ekis VRF. And here is the sites that we will be using. We will also create some filters to be able to establish the connectivity between the different VMs. This is multi-site orchestrator, where we will be configure a tenant and a schema, and we have two sites connected to it, AVS and VBDC, as you can see here. We will also create the tenant Ekis here. As you can see, we only have two tenants connected to MSO, but we will have a third tenant soon. In the APIC, you can see there is no Ekis tenant as well. In VMware, we will have our three VMs provisioned. This is how the networks looks in VMware. We will also configure 3 separated networks for these virtual machines. This creates a higher security for the application. The contracts will be created in the ACI infrastructure between those networks. Time to run the infrastructure as code pipeline. This will create the first application that the developer that I showed you before have been provided to GitLab. It will create 3 virtual machines in VMware and 3 network segments, both in VMware and in ACI. Let's fast forward until the pipeline is done. Yay! The pipeline has been finished successfully. As we can see to the right, we now have 3 new virtual machines, one for each part of the application. If we check in ACI, we now have a tenant called Ekis with an application profile called Miradot Services actually cached, which is the same name as the developer uses for its repository in the GitLab. It has 3 new EPGs. EPGs is like VLAN, but in ACI you can actually use those segments quite differently than in normal networks. Noticing that we have all 3 virtual machines in different network segments, but we actually are using the same gateway for all 3 networks. We also have a lot of contracts between these networks that are allowing only the specified filters that we have been created in ACI. Awesome. Now let's do another repository that also are running Flask and Redis with the MySQL behind it. So the only thing we need to do is adding that repository to our list of repositories that will be created automatically in the infrastructure. And we will push the changes to the GitLab, and it will trigger the pipeline automatically. As we can see, the pipeline has been successfully running, and if we check in ACI, we can, let's see here. We have now 2 application profiles, one for each repository in the Git, and it has its own L2 segments, but it will use the same gateway. You can see here it's 10.206.0, and here it also has the same subnet. And if we check in VMware, we can see now we have 6 VMs. What more can we do with this? We actually have a collaboration with a company called Opstis. This is a company that are customizing monitoring tools. They're using like Grafana and Prometheus to observe the infrastructure. This can we also use to get some insights in the application. So we can send the application metric to the same tool as we are monitoring the infrastructure. Opsys have been created a ACI exporter and also been created a dashboard for ACI. In ACI, there is a lot of health scores that can be used uh, to describe the health of a network. This can the infrastructure team use to provide some insights for each application, so the blame game can stop between the developers and the infrastructure team. Look, we now have both of our repositories in this dashboard. So each application will have its own dashboard. You can see at the left panel there is some information about application profile health and EPG health. And at the right panel, you can see the, the the metrics that the application is sending to Prometheus. By providing this kind of dashboards to developers, the infrastructure team can actually give some valuable information about the infrastructure that the application is running on. And see here, we can actually get some information for each virtual machine, what the CPU load is, how much RAM it uses, and more. As I mentioned before, we want a solution to scale out to the public clouds as well. So during burst hours, for example, we can scale out our web application and not losing the security policy that we are using on premises. We can actually create the exact same security policy in AWS by just adding a cloud APIC in AWS and connect that to our multi-site orchestrator. This creates VXLAN tunnels between your on-premises Nexus 9K switches and the CSR 1K in your cloud APIC in AWS. This makes it possible to stretch out, for example, a VRF to the AWS. And because ACI has a zero trust by default, we are not allowing any traffic more than the traffic that we specify in our contracts between the networks. This makes the solution also highly secure. Because we are using multi-site orchestrator to this solution, we can easily add AVS to the network configuration. So we have the same network objects that we have in our on-premises ACI. We can get those network segments in AVS. Here, for example, we have now a virtual machine in AVS running in a VPC in AVS, which is actually a VRF that are stretched out to AVS. This with the help of multi-site orchestrator. To wrap up this webinar, I just want to say that start with the low-hanging fruit in your organization. Start small and grow with that. Start with one developer team in your organization that you as the infrastructure team can collaborate with. Maybe they have some insight of and knowledge of how to automate in the clouds, and that can be reused in the on-prem. use the open source tools that are available. Ansible, Puppet, Terraform. Choose something that you are comfortable with. And if you need to kickstart your automation journey, why not have a call and we can maybe have a workshop together.